Okay guys, so this is going to be a quick run through of the main points that you need to be familiar with for your coming test, and we'll start with topic 1, and that's going to be percentages. So when we're working with percentages, we've got to think of equivalents. So for example, you've been asked to learn all your lists, so a half is the same as 50%, is the same as 0.50. A quarter is equal to 25%, is the same as 0.25. A fifth is equal to 20%, is equal to 0.20, etc. Now notice the connections. 5 times 20 is 100% the whole. So when we want a fifth of something, then we're saying how many 5s go into 100? 20. So a fifth is the same as 20%. And as a decimal, then we always turn a percentage into a decimal by dividing by 100. So if I've got something like an eighth and I want it as a percent, then I've got to ask myself how many eighths are there in 100, and basically we can go through. Eighths into 1 doesn't work, eighths into 10 is 1, leave remainder of 2, eighths into 20 is 2, that's 16, from 20 is 4, carry the 4 over, eighths into 40 is 5, no remainders, so it's 12.5%. As it's 12.5%, then as a decimal it'll be 0.125. Remember, there are other ways of doing this. You could say that an eighth is the same as halving, half again, and then half again. So a half of 100% is 50%, half again is 25%, half again is 12.5%. So there are several ways of thinking about how you can change fractions into percentages and back into decimals and so forth. So we need to be familiar with those percentage equivalents. We then need to be familiar with how we calculate with percentages. So for example, we might want to do 15% of £72, for argument's sake. So there's lots of ways of doing this. So we'll go through both the common methods. So 10% of 72. Well, 10% is the same as doing a tenth of anything, so that means dividing by 10. So the digits will move down one place value. So that's going to be £7.20. Be careful we do with money. And then 5% of 72. Well, the idea is that it's a half of the 10% value. So a half of £7.20 is £3.60. So add those together to get 15%, then we get £10 and 80p. Again, really important, we need that extra zero to make sure it's proper money, £10 and 80p. So that's one way. On a calculator paper though, we've got to remember there's things called percentage multipliers, and therefore we could have done 0.15 times 72. On our calculators we'd have got 10.8, but then we remember it's about money, so we'd have put the extra zero. So there is a quick way of doing percentages on a calculator. We can divide the percentage by 100 to get the percentage multiplier, and so this is called the percentage multiplier because you're multiplying by it, and it's a percentage multiplier equivalent, and when you do that sum, I say it's £10.80 on the calculator. If you want to work with percentage multipliers, then for example, if I increase by 7%, say, then I now have 107%, because I've got my original 100% plus the 7%, and as a percentage multiplier, well, we turn a percentage into a decimal by dividing by 100. So as a percentage multiplier, increase by 7% will be the same as timesing by 1.07. If I've been asked to work out something with what's called a reverse percentage, and we notice those kind of questions when they say things like find the normal price, find the original price, price 2 years ago. So if they're saying things like that in the exam questions, then they're asking you to reverse. So let's have a look at an example. So they might say something like a car was sold for £3,600 after a 40% loss in original value. Basically, what was the original value? Well, these kind of questions we've got to ask ourselves, well, what's it all mean? Well, we had an original value. We lost 40%. Well, that means we're left with 60%. So that's the same as timesing by 0.6. And that gave us the answer of 3,600. So I could reverse the process to get what the original value was by doing 3,600 divided by 0.6, which is the same as doing 36,000 divided by 6, multiply everything by 10, and then 36,000 divided by 6 is £6,000. That's one way of thinking about reverse percentages. I could have thought about the 3,600 was the same as, so we could have said equivalently, 3,600 is equivalent to 60% of the original value. So I could work out what 1% of the original value was, and that would be by dividing by 60. So I'd have to divide this by 60 as well. And 3,600 divided by 60 is 60. 36 divided by 6 is 6. 2 zeros divided by 1 0 leaves me with 1 0 left, so 60. And then of course I want to get the original value altogether. So 100% equals the original. So I then times up by 100. And 60 times 100 is £6,000. So the same answer as what we got through the flowchart approach, the reverse approach. We can do it by equivalent percentages. The key to this, though, always is to think, what have I actually got left by doing the question? The question said there was a 40% loss, so I was left with 60%. So everything hinged around the value I know was the same as 60%. So that's a reverse percentages question. If I had to do an investment question, so say I did an investment of £2,000 for 3 years, interest rate of 5% compounded, then this is the kind of question where a percentage multiplier would be useful, because we're asked what is the value of the investment after 3 years. So basically each year the value is increasing 5% more than what it was before. So an increase of 5% means I multiply by 1.05. 100% plus the 5% increase, 105%, but as a decimal is equivalent to 1.05 as the multiplier. But that's happening each year. So basically every year everything's increasing by 5%. I'm doing it for 3 years, so I actually just times by 1.05, times by 1.05, times by 1.05 3 times. Well, that's the same as doing times by 1.05 cubed. Well, what am I timesing by? Well, the original investment, the 2,000. So on our calculators we would 2,000 times 1.05 to the power of 3, so cubed, equals, so £2,315.25. So that would be how to do those kind of questions where they're talking about an investment of so many years, compounded interest, what is the value of the investment for 3 years, work out what my percentage multiplier is per year. 5% increase means 1.05, but I'm doing it for 3 years. So that basically is the number of years. That's my percentage multiplier, and that's my original value. and in doing that we find out what the new value is. So that's a run through of percentages and things that you need to be knowing about percentages. So how to find the percentage of a number, how to do equivalents, how to work out percentage multipliers, how to work out increases, and how to work with reverse percentages, and how to work with compound percentages. Hope it's of use.